classical electric field at an equatorial point of the dipole. So in the first case, at coaxial point we had found the electric field of the dipole, right? So today we have not completed this topic in the class. Simply we will complete this topic how to find the electric field, total electric field due to the charges of the dipole. So in a simple diagram we have just shown this is the point P where we have to obtain this electric field. That is the resultant field at this point which we have shown. This is the direction of electric field due to charge plus Q, and this was the direction of electric field due to charge minus Q. This line was the perpendicular distance from the axis of the dipole. Now we are just showing the components of these fields, in which this was the direction of electric field, and this is angle theta. This is also theta. So the components of this E plus P, just see. This is the vertical component and this is the horizontal component. This just I have shown the class E plus Q cos theta. This is the for E plus Q, this component along this direction of the electric field, and this is the perpendicular E plus Q sin theta. These are the vertical and horizontal components of E plus Q. Now the two components of this E minus Q. This is vertical component, so simply it will be minus Q sin theta, and along this is angle theta. It will be again E minus Q cos. So you can write there minus. So this common or simply these components refer to plus Q cos theta and minus Q cos theta, and these components which are perpendicular to the axis of the dipole, perpendicular and opposite, so they will cancel each other, right? So we had just got that the total electric field which can be add up while E is equal to E means simply total E plus Q plus E minus Q. So E plus Q and E minus Q. In both the cases, the components that cancels each other, the remaining that is simply plus Q cos theta. E plus Q cos theta plus E minus cos theta with negative sign. Why negative sign? Because this electric field is just opposite to the direction of the dipole moment. Electric dipole moment or simply the dipole moment. In between the class, don't try to enter. I have just warned you all. Within 5 minutes of starting, you have to join the class. I will simply focus on the study. Just see. This is the total value that has been simply added up. Clear na? Let's see. So these two components, these negative signs show that these are in the direction of the electric field which is opposite to the electric dipole moment. So you can just simply write there. We will just substitute the value of these components, then we will find how can we calculate such type of the value. Okay, so till here we have just discussed in the class view. Now we will discuss further. We will put the value. see the diagram in the classroom we have just two. I will just erase and have a calculation. Just note on this diagram. Just see, this is E plus T minus T. Earlier we had shown both are equal. Earlier we had shown that E plus T is equal to E minus T. So if you take or use this relation, it can be written as minus 2 plus Q can be written minus Q. You can also write E plus Q. We will substitute the value of minus Q or plus Q. So this can be written as the value. Is it visible to all? So the value we had written of the E plus Q or E minus Q good earlier when we had started to write the magnitude we had just seen. So just see minus 2 E minus Q or E plus Q both have having the same magnitude, only there is difference of the sign. So you can write Q this cos theta and divided by 4 pi epsilon naught, and instead of the magnitude of the distance, this was simply r and this was r square plus a square, which we had just shown how the square had disappeared see earlier we had written E plus Q is equal to 2 by 4 pi epsilon naught r square plus a. So we have just simplified mathematical calculation. Just see. Now I will erase this diagram. हाँ जी बोलो नहीं आ रहा है वीडियो यहाँ तो साफ आ रहा है नेटवर्क इशू हो सकता है देख लेना अगर वैसा होगा तो रिकॉर्डिंग आवाज क्लियर नहीं आ रहा चलो यहाँ फैन भी बंद कर दिए अब उससे शायद आवाज कैलकुलेशन को ध्यान से देखो अगर आवाज में दिक्कत होगा तो लोग कैलकुलेशन को गौर से देखेंगे नाउ वी विल पुट द वैल्यू ऑफ दिस cos theta in the figure which we had drawn in the classroom. This electric field can be written as we will just substitute this cos theta. See, this was perpendicular. This was the value of r. This is a, and this was r square plus a square over half, and this was simply theta. So what will be the cos theta? Just see, cos theta is equal to b by h, a by r square plus b square power half. So we will just substitute this cos theta in this formula or in this equation. So just put the value. You can write minus 2 q and this a sorry, divided by 4 pi epsilon naught 4 pi epsilon naught r square plus a square, and this is r square plus a square to the power half. So r square plus a square and this is half, means 1 and half 3 by 2. So this is r square plus a square power 3 by 2. Just see, this is the final calculation which we have substituted the value of cos theta and then we have obtained this value. Now what to do next? Just 2qa. This is equal to the dipole moment P. So you can write E is equal to 2q. 2a was the simple length, and what? It was q, that is the charge. So it can be written as minus P divided by 4 pi epsilon naught r square plus a square 3 by 2. Just see, in the this form you can write. If you want to introduce the unit vector, there another unit vector method where you can write this P is the unit vector. This P is the, why we have written P? This is electric dipole moment, which is equal to the product of either of the charge and the distance between them. So either of the charge, Q, distance is twice of A. So in this way, this is the value of the electric field at the equatorial point of a dipole. Just see, we will consider in the previous case we have just since this r is much greater than r, r is the perpendicular distance, a is the very small distance, because in the case of the dipole, two poles are separated by very small distance twice of a. So a will be very very less. So what will we do? We will simply neglect the magnitude of the a, because if a is very very less, its square will be also very less. So this can be neglected. So what will happen here? You can write therefore E is equal to minus P divided by 4 pi epsilon naught. A square cancel, R square 3 by 2 cancel, R cube. R cube, this is P like the unit vector. So this is also one of the form in which we can represent the, just note down. And one more thing we will write, we will just compare from the first case. In the case of the axial point, this E was simply twice of P 4 pi epsilon naught R. Same quantity was there, only this time was positive and two term was there, two was there. So what is the difference? There it was positive, there negative. Negative means this electric field just act to the direction opposite to the direction of the electric dipole moment. In the first case, axial point, simply this was the direction of dipole moment and this was also the direction of electric field. Here, electric field is negative sign. This negative sign shows this electric field acts opposite to the direction of electric dipole moment E. After writing this, you will write negative sign shows E acts opposite to the direction of dipole moment. Just note down. Here you have to write negative sign shows E acts opposite to the direction of electric dipole moment P. This is the negative sign. Just note down. Clear to all of you? Just note down the calculation and just compare the previous value and this value. Only sign is different and one constant term 2 was there. Any problem? Then you can ask. And if you have noted down, just say I can erase and I will move further. हाँ जी हो गया. फार्मूला जो जनरेट किए हम लोग दोनों लिखोगे ब्रैकेट में फेरोगे, ये हमारा है जनरल फार्मूला, and when we have just compared the quantities, then after reducing this or neglecting this term, this will be simplified like this. In both the term you can just write this P what electric dipole moment. It can be also written. ओके, नोट डाउन, इरेज करें, चैट बॉक्स में लिखो, हो गया तो यस और नो। चलो अब आगे बढ़ते हैं। ध्यान से देखना, जो हम इलेक्ट्रिक फील्ड निकाले थे किसके, एक्सियल के लिए, ध्यान से देखना, उन दोनों के बीच में रिलेशन निकालते हैं, ई एक्सियल और ई इक्वेटोरियल बीच में। तो देखो इलेक्ट्रिक फील्ड डाइपोल का, इलेक्ट्रिक फील्ड ऑफ आ डाइपोल due to you can say, or simply at you can say, simply dipole at an axial and this equatorial point. Just see, this is simply the formula we have written, ax for axial, ax for axial. Just see, we had just obtained 4 pi epsilon naught, and we had just written 2p by r cube. Just see previous record. If you can write unit vector, you can also write. And e equatorial, just we have obtained is 1 by 4 pi epsilon naught, this will be minus p. Here it is only minus p by r. So just see the difference. This minus and this is only two constant term, 2 is present there. So on this basis, you can write E axial is twice of E equatorial. So you can write E axial is equal to twice of, we are just comparing the E equatorial. This is the relationship on the basis of the value we have obtained. Note down. So just note down this relation we had obtained yesterday. Today we had obtained this formula. So after this discussion and explanation, we can correlate them, how they are related with each other. Clear? So now we will move forward with some of the new word about which we have discussed in class 11 earlier. So in class 12 we have to discuss. Now instead of this dipole, again we will move with this particular term. When this dipole will be placed in uniform electric field, what will happen there? So just remind, this parallel lines having some direction can be represented for uniform electric field lines. This represents uniform electric field lines. We have discussed the characteristics, properties of the uniform or simple electric field line. So now, what will happen if a dipole is placed in some type of electric field? What will happen? So just see, in the case of this, what will happen? It will experience a force on its two ends where the charges are placed. Both will be the equal in magnitude. That will cancel the effect of each other. But in the case of torque, we have here, it is simply the turning effect. Turning effect means, suppose this two forces are acting on this field. Suppose this is the dipole. One force is acting in this way, in this direction, another in this way. What will happen? Suppose both are of equal magnitude. In the case of the balanced force opposite to each other, the body remains in the same state. But here, it is acting at some of the angle. It is in this way, it is in this way, opposite, and it is at the, not at the same point. Take care. In the case of balanced force, the point is simply considered to be the same. But here, it is acting at two different points. So, when having the equal magnitude, they will create the turning effect, and that will appear in the term of the torque. So simply the magnitude will be zero, or simply it can neglect each other, but the turning effect will be produced, and that is known as the torque. So our next topic is to find that torque. So just see. ठीक है जी, आप थोड़ा बड़ा कर दे रहे हैं. Topic is torque on a dipole. This time target is this torque we have to find. So torque on a dipole, where it has been placed in a uniform electric field. Torque on a dipole in uniform electric field. This is our topic. So this torque, this is the vector quantity tau, and one thing more I would like to remind in class 11 in rotational dynamics we have gone through this formula. Torque is simply equal to the r cross f. R cross f, this f was the force and this r was the perpendicular distance. Perpendicular distance. So in this case also we see how the turning effect is produced in the form of the torque. So first of all we will draw a diagram. We have a uniform electric field. After that we will show. So just see, try to understand the diagram. This is simply the electric field, and here we are just showing this is simply a dipole minus q plus q. So this is the distance that is always represented by 2a. So here you can show this distance as 2a. So this is placed in uniform magnetic field in this way. These small lines are parallel, which shows the electric field. So perpendicular lines that show the uniform electric field in which the dipole has been placed at certain angle. This is simply the angle at which it has been placed. That is the theta. Just see. This is dipole which has been placed in uniform electric field. Parallel line shows uniform electric field. So the force on this point, electrostatic force, we had shown electrostatic force Q dot E. This was electric field which we had shown F by Q dot. So this F is E into Q. So the force due to that particular field experienced at this point will be what? Q E. Just see. Q E. Q means plus Q. This is plus, not activity plus. And this is simply in this way. In this way. This is minus Q. This is negative charge and will experience the force in this way. Now, this distance, just see, This is 2a, this is theta. See, if you find the value of this perpendicular distance, how will you find that particular distance? So this will be simply 2a sine theta. This perpendicular distance will be simply 2a sine theta. So why it is sine 2a sine theta? Suppose this is x. If you take the value sine theta, p, p by h, x by 2a, so x will be 2a sine theta. X. So directly I have written 2a sine theta. I am not going to write x. If you want to write x is equal to 2a sine theta, how this 2a sine theta have been found out, you can write why it is 2a sine theta by x. You can write this. So just you have understood this particular diagram. Main focus is to understand the diagram. If you have understand the diagram, further calculations are very simple. Whatever we have learned till now, we will simply implement those and then we will find the particular diagram. So just note down the formula or diagram. After making understood, I will move forward. Okay, it's a clear for all of you. There is no any problem to anyone. So this is the electric field and parallel lines represent uniform electric field. So the dipole has been placed at such an angle theta. Okay, just do fast. We have to complete this within some of the minutes. Complete the diagram. I will erase it forward. So one by one, we will write about this. This is the force experience at this particular point, and this is the force experience at this particular point. Why? Because this dipole has been placed in an uniform electric field. So plus q charge will experience force, minus q charge will also experience force. So you can write therefore force experienced by charge plus q. Just see, we are just writing about this. What force it will experience? Okay, by force experienced by charge plus q by electric field E. By electric field E. Just see. Due to electric field, it has been placed. So it will what? It will experience a kind of electrostatic force. So how that force can be found? F is equal to Q into E. So that will be the value of it. So this will be plus Q E. Let's see. So this is the magnitude of the force acting on that. So this is along the direction E. Along E means electric field along it will act plus Q. When you will find similarly, you can write the also or and force experienced by charge minus Q by electric field E is equal to minus Q E. This time it is just opposite, not along. It is opposite to E. Opposite to E. Is it clear to all? Just see. Just see. So both are same in magnitude, but the direction are opposite due to the sign of the charge. So just note down. Do fast. So two forces are there. One at this, one at this. Total we have to find. Now I'm going to erase. So the total force, these are the forces I have given here. Yes, force. So the total force experienced by this torque. So you can write F total force. So what will happen there? Plus QE plus minus QE. Just see, plus QE minus QE. It will experience the zero force. Zero force means resultant force will be zero. So if the torque is called, then you will say, sir, if the total force is zero, how the torque will be called there? So once again, I am telling you, just see the diagram. Suppose this is the force, this is the point of the action of the forces F1 and F2. So along the same point of action, both are acting. So if F1 will be equal to F2, their magnitude will be same but in different direction. So they will cancel each other. So the total F2 barabar 0. But here the action point is different. One force is acting at this point, another is along this. So it will cause a turning effect. That turning effect is known as torque. So here resultant force is zero, but still due to the action point different, the torque will be produced, and that torque makes it to move or rotate. Okay, so just note down. After this we have to write, after that we will mention the term torque with the help of the formula. Okay, so after that we will give explanation why even it is zero but still a torque is being produced. Okay, so you can write net force, net or total force on a dipole. Figure I have just erased, so you have to see. So net force on a dipole where in uniform electric field is zero. Now this has been written in the form of language, and after that there will be the creation of torque. Just see, but these two forces are not acting at the same point. The points are different. Once again, I tell you, same along the same line of action. The point of action is same. The resultant will be zero. There will be no change in the position. But if the direction is different, one along this, another along this, and point of action is different, it will cause the turning effect, and that turning effect is simply known as torque. In class 11 we have just understood in the case of the door, when the door is pulled and pushed, it provides the turning effect. That turning effect is known as torque. So just complete till here, we will move forward. Just after writing this, we have to create the term torque. Torque means this symbol, torque. How it will be created? So my language is not clear due to the network problem. That's why I am writing whatever I am telling. I am also writing because you all are belonging to the different area. So just you write here. After this you can write, but 2. Just once again see. This was the two different points where minus Q and plus Q charges. So one force was acting along this, another was acting along this. Direction is again different, but point of action is also different. And if it was same, then that we have no production of the torque. Okay, so that due to the different point of action, line of action, torque has been different. So just write the language in the form of a statement. I have just seen today the syllabus. I have noted down some of the parts I will get from the syllabus. So I have just noted down. I will also discuss in the class about that which we have to not study. Okay. So just complete. But two equal and opposite forces. Two equal and opposite forces plus QV and minus QV. Just it will complete the topic. But two equal and opposite forces act at different points will produce, okay, a torque. Points of a dipole causes a torque. Just see and note down.